Hi, today we want to present our case study about environment recognition system, which is the application of the machine vision subject. For the environment itself, we can choose the classroom environment, which is quite close to us as a student, the every learning in class. First thing first, what we want to share in the classroom environment recognition is about how machine vision system can recognize object in the classroom by using image of the object. For our case study, we only provide 3 of object, which is chair, whiteboard, and door. Why we do the research about classroom environment recognitions? Basically, we want to do inspection on a broken class instruments, such as door, chair, and whiteboard. So, by using machine vision system, the system will recognize those instruments and reassure that it can be used. But when our system cannot recognize the instrument, we can confirm it cannot be used anymore, because for sure those broken instruments will not have true shape and feature anymore.
Based on a machine vision concept, we have been through steps and process in order to complete the classroom recognition. First thing is image acquisition. Image acquisition can be defined as the act of procuring an image from sources. Our source is basically the classroom environment itself, and we need to get the image based on our target objects or instruments in the classroom, such as door, chair, and whiteboard. We procure the image by using our own phone camera to capture those instruments. Next is image processing. After we upload to input the image in the MATLAB, we process the image by using a few concepts such as grayscale, threshold, erosion, and dilution. As a start, we need to convert the image to grayscale by using RGB to grayscale in MATLAB. This must be done because grayscale approach can increase the recognition accuracy in a variety of situations. After that, using that grayscale image, we must convert the image to binary image by using Otsu threshold method. This method is used to automatically perform histogram shape-based image thresholding, or the reduction of a grayscale level image to a binary image. Next, we need to apply the basic morphological operations, which is erosion and dilution. The erosion is used to remove floating pixels and thin lines so that only subtractive objects remain. Remaining lines appear thinner and shapes appear smaller. For the dilution, is basically making objects more visible and fills in small holes in objects. Lines appear thicker and fill shapes appear larger.
Feature extraction basically is a technique to get image classification and recognition relevant features. In machine vision or computer vision, it is quite necessary to distinguish one object from another. This is accomplished by means of features that uniquely characterize the object. We have come up with 2 sets of folders of images that we'll use for training and testing dataset feature. For our case study, we use few global features such as perimeter, area, circularity, and major length of our selected instrument. As we can see here, these are few data that we gained from global features that were extracted from training folder. Pattern recognition is a technique of assigning patterns to their respective class. Based on our feature extraction, we select the most advantageous feature. So we chose area and length feature to make the best visible difference between object data. So as we can see here, these are the scatter plot of training dataset feature. In order to obtain centroid class on feature area and length, we need to use K-mean cluster method. This method algorithm can group our data into K numbers of categories. The principle is to minimize the sum of squares of distances between the data and the corresponding cluster centroids. As we can see, the scatter plot of centroid class of feature area and length here. So by using testing folder, we can extract the data from images to determine the features, and then we will know how exactly to classify the class based on the feature. So we can use k-means classifier with unsupervised method in order to obtain the distance between the data, as well as we can see here the scatter plot of k near neighbor. Why KNN method? Because this method is very powerful classification algorithm. We can classify based on the similarity of the measure. We only can do this whenever we got the data from training folder dataset.
What can we discuss from our case study? Basically, we need to make sure our machine vision system can recognize classroom instruments like door, chairs, and whiteboard, all based on this process that we have been through step by step. As we explained before, we have come up with two folders of images, which is testing folder and training folder. From training folder, we can gain so much features like area, parameter, circularity, and measure length. Then, we can do this classification techniques by using clustering process, which we have illustrated by scatter plot based on each cluster. The scatter plots reveal three centroids that are essentially located among the groups. The fundamental premise is to minimize the sum of square of the distances between our data and the cluster centroids. Last but not least, we do the testing folder in order to determine those instruments that we want to be recognized. 12 images with 3 for each object, we can get the new data that have been organized into clusters. Using clustering method in MATLAB, the characteristics derived from the data obtained were used to generate the scatter plots. This centroid will serve as the standard for the new data collected by each group. Based on k near neighbors, we can illustrate the scatter plot demonstrates the classification is based on the majority vote for the neighboring class.
Based on our objective, we want the machine vision system can recognize classroom environment perfectly in order to detect that the classroom instrument broken or not. If the system can detect, that means the instrument have no problem and can be used. So from all over the process and result, we can now have the machine vision system that can collect the data from images of classroom instrument in order to recognize and simply to conclude the condition of the object. Based on this, we can also know that whenever the system cannot recognize, the object itself must have problem and cannot be used. That's all from us. Thank you.